Sir, your voice is not audible, sir.
Sir, not able to hear you, sir.
Yes, sir.
Sir, we are able to see the screen and not able to hear you, sir.
Yes, sir.
Okay. Am I audible now?
Yes,
Yes, sir.
sir. Yes, sir.
Great. Okay. Have you noted down this numerical which I shared earlier? If you not noted, you note down which is this numerical. You are going to solve now. You can note this numerical afterwards. So what is given in this numerical? At a certain point in an unconfined aquifer of 3 square kilometer area. So the area of the unconfined aquifer is given as 3 square kilometer. The water table was at the elevation of 102 meter. The water table which is measured, the elevation of water table is 102 meter, and due to natural recharge in the wet season, its level rose to 103.2. So due to the recharge, its level rose to 103.2 from 102. That means rise of 1.2 meter. A volume of 1.5 million meter cube of water was then
कौन सा नाम क्या
What happened? What happened? Am I audible or not?
Yes, sir, you are audible.
Okay. So due to recharge, the water level rose by 1.2 meter. Then the volume of 1.5 million meter cube of water was then pumped out of the aquifer, causing the water table to reach to a level of 101.2. So after recharge, this water table in the entire aquifer to respond in a similar way. Estimate, you have to calculate specific yield of aquifer, and second, the volume of recharge during the wet season. So how do we solve this? Has anyone thought on this? Okay. Can anyone tell me? Nirmala,
Sir,
how do we solve this? Any wild guess or what's your thinking? We know how much is the drop in the water level. We know what is the area. What is the volume? Normally, if you just consider your water tank or any reservoir, if you know the area of reservoir, if you know how much is the depth at which the water table has changed, can't we calculate the volume? You can calculate the volume now. So
it is
here,
that time.
yeah, so here volume is given, depth is also given, area is also given. The difference between above surface and below surface is the specific yield. So when you multiply a volume with the specific yield, you get the exact amount of water that is you can able to pump, because specific yield is the ability of water to ability of aquifer to release the water due to gravity. So when we solve for first part, volume pumped out is nothing but the your area of aquifer into drop in water level into specific yield. So this specific yield is the basically the difference between the water behavior of water above the ground level and below the ground level. Below the ground level, this specific yield plays the role. Now we know what is the volume that is pumped out. It is given here as 1.5 million meter cube. So I will write 1.5 into 10 to the power 6 million means 10 to the power 6 converted into meter cube. So this is equal to, what is the area? Area is given as 3 square kilometer. So I'll convert into meters square. So 3 into 10 to the power 6 is the area. How much is the drop in the water level? Is 103.2. This is after recharge, then only the pumping started. That's what's mentioned in the problem. So 103.2, and it fell down to 101.2 into specific yield is, we have to calculate SY. Solve and tell me what is the specific yield value you are getting it.
Point 0.25, sir.
0.25. All of you are getting.
Yes, sir.
Yes,
Yeah.
sir.
Will there be unit for specific yield? It is not having any
No,
unit.
sir.
So
No, sir.
specific yield is dimensionless. We just say it is 0.25. Means what does exactly this means 0.25? This means that the aquifer, if you consider it is complete saturated, it releases only 25% of the water and 75 due to the their molecular attraction between the soil particles and water. So Sy becomes 0.25, and if you want to calculate the water that is retained, Sr, that will come as 0.75, 75%. In that way you can conclude. Now what is the next part? The volume of recharge into the wet season. How do we calculate recharge volume? Same formula. Area, since it is recharge, water level will increase. So rise in water level. When you pump, it will fall down. When you recharge, it will increase into the specific yield. Substitute and calculate. Area is 3 into 10 to the power 6. Rise is 103.2 minus 102 into specific yield is 0.25. How much you are getting?
One point five into 10 per 6, sir.
How much?
1.5 into 10 power 6.
Are you sure? Here it shows
9 lakhs, sir.
yeah, 9 lakhs. 9 into 10 to the power 5.
Uh-huh.
9 into 10 to the power 5 meter cube, or if you want to write a million meter cube, it is 0.9 million meter cube. Okay, all of you got the same answer?
No, sir.
Check your calculation. 3 into 10 to the
Yes,
power.
sir.
Yes, sir.
Check who those who didn't get the answer. Check your calculation. Okay. Shall I
She's
move to the
taken
next?
1 or 2 as not 1.2, sir.
Okay. We have to see, no? Initially it was
Not to, sir.
102. Yeah. Initially it was 102. After that recharge take place. Then it rose to 103.2. So rise in the recharge will be 103.2 minus initial level, that is 102. Okay. Now shall I go to the next one?
Yes, sir.
So next one. given. It's for the confined aquifer and it's a well hydraulic problem. A 30 centimeter diameter well completely penetrates a confined aquifer of permeability 45 meter per day. So a 30 centimeter dia bore well is dug into the confined aquifer and has the aquifer permeability is 45 meter per day. The length of strainer is 20 meter. That basically indicates the thickness of your confined aquifer. Strainer is nothing but we put perforated coatings. So we put for the aquifer region, saturated region. So that is 20 meters. So that means the B value, that is the thickness of your aquifer, is 20 meters. So under the steady state of pumping, the drawdown at the well, it was found to be 3 meter and the radius of influence was 300 meter. Calculate the discharge. So how do we solve? First we'll note down what is the data that is given. A 30 centimeter dia well. So diameter of my well is 0.3. That means my radius of my well becomes 15 centimeters, so 0.15 meter. Second. Then what is the next data that is given? K value. Okay, right here. K is given as 45 meter per day. So this I have to convert it into meter per second. So this is the value we will be using in our equation. So convert this into meter per second. So meter per day. So it will be 45 divided by 324 into 60 into 60. How much?
5.20 into 10 power minus 4.
5.20 into 10 to the power
8 minus 4.
minus 4. So 5.208 into 10 to the power minus 4 meter per second. Then what is the data? Other data that is given. The B is given as 20 meter. SW small s, that is the drawdown at the pumping well, is 3 meter. And another data that is given, the radius of influence, that is capital R, is given here as
Sir,
300.
your voice is breaking, sir.
Okay, is it clear now? Still breaking?
It's clear, sir.
Okay, so this is the data that is given. So we know what is the radius of the pumping well, 15 centimeter, that is 0.15 meter. Permeability, that is K, 45 meter per day, that comes to 5.208 10 to the power minus 4 meter per second. B, that is the thickness of the aquifer, that is 20 meters. Drawdown at the pumping well 3 meter, and R given here as 300 meter. I think even the radius of influence, it is given. What equation we should use? Told you in the previous class.
Q
Refer
is
your
equal
note.
to pi k h2 square minus h1 square
That
by
is
ln
for
r1. Sir,
unconfined aquifer. This is
sir,
confined
it is
aquifer. When that square term comes now, that is for unconfined aquifer. For confined aquifer, what is the equation?
T equal to KB. equal to Q by 2 pi H2 minus H1 ln of R2 by R1.
Okay, and when the radius of influence is given, that equation will reduce to, in second I'll open. Just hold on. So for steady flow in a confined aquifer, this is our basic equation. T is equal to, that is Kv, that is equal to Q divided by 2 pi H2 minus H1 ln R2 by R1. This can be reduced to this form when you know the drawdown, and if you want to, and with respect to Q, it is 2 pi T S1 minus S2 ln of R2 by R1. So this equation we use when we know the water levels of two adjacent wells. Now, if we know the radius of influence and if you know the drawdown at the pumping well, this equation will reduce to this form. Q is equal to 2 pi T SW ln of R by RW. Okay, so in this one, what happens? Your S2, when you are calculating at radius influence, what is the thing? Your drop in the water level is 0. So your S2 will become 0. S1 will be the SW, and your R2 will become capital R, and R1 will become RW. So when the radius of influence is given, we should use this formula. Q is equal to 2 pi T SW ln of R by RW. It's a simplified way of this one when the radius of influence is given. Okay, so we are going to use this formula. It's that formula. Q is equal to 2 pi T SW ln of R by RW. Correct? Am I audible?
Yes.
Okay.
Yes, sir.
Yes, sir.
Sometimes you guys become so silent, I get it out whether I am audible or not. So here all the datas we know, only we have to calculate is the T. So what is the T? T is equal to K into B. T is transmissibility, that is equal to permeability into the thickness of the aquifer. Permeability is 5.208 10 to the power minus 4 multiplied by what is the B value, that is 20 meters, that is the thickness of the length of the strainer, that's equal to the thickness of your aquifer. What's the value?
0.0104.
0.0104. What is the unit of transmissibility?
meter square per second.
Correct, meter square per second. And see, so this is conductivity of your permeability is meter per second multiplied by the width, that is thickness, that is in meter. So it will be meter square per second. That is the standard unit of transmissibility. Don't write meter cube per second or meter per second. Now calculate your Q. 2 into pi into 0.0104 into SW is 3 divided by, you have to use natural log ln. R is 300 by RW is 0.1 pi.
0.0257.
0.0258 meter cube per second. Correct? So this is the discharge from the that pumping well. If you write in liter per second, this will be 25.8 liter per second. Got it? Anyone has any doubt in this one, in this numerical? Shall I proceed to the next one?
Yes, sir.
This is also a numerical on confined aquifer. So here basically the levels of adjacent two pumping wells are given, and with respect to that we have to calculate the transmissibility and permeability of aquifer. So what's the problem is the discharge from the fully penetrating well operating under steady state in a confined aquifer of 30 meter thickness is 2100 liters per minute. So aquifer is confined, thickness, that is B, is 30 meter. So I'll start writing B is equal to 30 meter. It's a confined aquifer. Q is equal to 2100 liter per minute. Convert it into meter cube per second. So 2100 liter to meter cube divided by 1000 minutes to second multiplied by 60. Correct? 1 minute has 60 second and 1000 liter is equal to 1 meter cube. So that's why divided by 1000. What's the Q in meter per second?
0.035.
0.035 meter per second. Correct? So this is the our discharge in meter per second.
Sir,
B is
meter
given.
cube, sir.
Sorry, meter cube. Meter cube per second. Then what is given? The drawdown observed at the two observation wells located 15 meter and 150 meter, 3.2 and 0.28 meter respectively. So drawdown is, I'll write my symbol for drawdown is S. So S1 is 15 meter, R1, sorry, R1 is 15, S1 is 3.2.
R150.
Yeah, correcting it. So S1 is 3.2, R1 is 15 meter, S2 is 0.28 and R2 is 150 meter. Determine the transmissibility and permeability of aquifer. So what is our equation? If you write in terms of T, transmissibility of confined aquifer is equal to T is equal to Q divided by 2 pi you remember the formula in whichever way you can rearrange. So if you remember in forms of Q is equal to 2 pi T S1 minus S2 divided by ln of R1 by R2, that way also okay. Then you can rearrange and calculate the T, or if you remember this way also is fine. So Q is equal to 2 equal to pi S1 minus S2 ln of R2 by R1.
4.392 into 10 to minus 3.
Okay. Put value Q 0.035 2 pi is 3.2 minus 0.28 to ln of 150 by 15. How much you told?
4.392 into 10 to minus 3, sir.
Okay. 4.39 10 to the power minus 3 meter square per second. That is the unit of transmissibility. Now, can you calculate the K? That is the first part. So T is equal to K into B. So your permeability is equal to T by B. So T we got 4.39 10 to the power minus 3 divided by B is 30. So what is the permeability?
1.46 into 10 to minus 4.
How much? Tell me once again.
1.46 into 10 power minus 4 meter.
1.46 into 10 to the power minus 4 meter per second. So this is the permeability of the aquifer. Okay. So this numerical
Yes,
is
sir.
clear. No doubt. Okay. So these two numericals, similar numericals, will come for confined aquifer, and for unconfined aquifer, we have a numerical like this. A 30 centimeter well completely penetrates an unconfined aquifer of saturated depth 40 meter. So your okay, 30 centimeter well, so your RW will become 0.15. My B value is 40. After a long period of pumping, steady state rate of 500 liter per minute. So my Q value is 500 liter per minute. I'll convert it into meter cube per second. So 500 divided by 1000 into 60. How much?
8.3 into 10 power minus 3 meter cube by second.
8.3 into 10 to the power
Minus 3 meter cube per second.
meter cube per second. Now, what is given? The drawdown in the two observation wells, 25 and 75 meter from the pumping well, were found to be 3.5 and 2 meter respectively. So S1 is equal to 3.5. Remember, this aquifer, it is unconfined. So unconfined, we should have the values in the form of piezometric head, that is H value. So if you want to calculate your H1, H1 is equal to your saturated thickness minus S1. So this is equal to 40 minus 3.5. See, drawdown is the height we measured, water level we measured from the ground level. In the unconfined aquifer, we require a data, that is the water level data from the bottom of the aquifer. That's we call it as a piezometric head. So that is equal to your saturated thickness minus your drawdown. So that you will get it H1. Why we require? I explained in the last class, because there is a square term comes. So that is why we cannot replace H1 with S1. So normally S1 minus S2 is not equal to H1 square minus H2 square. So that is why we have to enter the value with respect to piezometric head. And my R1 is 25 meter. S2 is 2 meter. Okay. My H2 will be B minus S2, 40 minus 2, that is equal to 38 meter. this should be equal to 36.5 meter, and R2 is 75 meter. Now if you want to calculate the discharge through unconfined aquifer, what is the formula? Your Q is equal to pi K H2 square minus H1 square divided by ln of R2 by R1. Substitute value of Q we know, H2 H1 we know, R2 by R1 we know. We can calculate the K. Substitute and calculate the K value and tell me what K value you are getting. What is the K value?
2.6 into 10 power minus 5.
2.84 into 10 power minus 6.
Check it once again. I also don't know the exact answer.
2.59 into 10 power minus 5.
2.59 into 10 power minus 5.
2.59. Tell me whether this is correct or not. Okay. This value is correct. 2.59 into 10 to the power minus 5. Majority of you are getting this value.
Yes, sir.
Yes,
Okay.
sir.
Now, what is the transmissibility? T is equal to K into B. So, K is 2.59 10 to the power minus 5 into B is 40.
1.036 into 10 power minus 3 meter square per second.
1.036 into 10 to the power minus 3 meter square per second. Okay, so this is the transmissibility. Now what is the second part, that is as what is the drawdown at the pumping well? So when you go for the pumping well, your wells will shift. There we'll consider the first the R1, that is equal to at the edge of the well, that is my RW 0.15. So R1 will become RW, R2 will become the next adjacent well. So that is here in this case it will be 25 meters. So your R1 will become R2 and your H2 is the next well. So that that will be the for this well where the drawdown is 3.5, and your H1, that is the that will become the drawdown at your pump sorry, pumping well. So try to solve that one. So now, if you are not able to get it, then I'll explain it in the next class. So I'll be taking 12:55 class today. So there will complete this numerical. Okay. So
Okay,
till
sir.
here it is fine, no? So we just try to attempt. If you're not able to solve it, we'll solve it in the 12:55 class. I think I'm meeting your break time. So I'll stop here and then we'll complete it in the 12:55. I'll just note down your attendance. Okay, guys. Thank you.
Thank you,
Thank
sir.
you, sir.